Hey all you cool sabers! Today we're going to take a look at vector addition and subtraction. So the first thing we're going to talk about is the triangle law, which is to find, if we're trying to find the sum of two vectors, what we're going to do is we're just going to build a triangle out of them. It's fairly obvious based on the name, but so if we start with A, so there's A, okay, and what we do is we take B and we just put the tail of B right at the head of A, and we just add it to the front like that. And what that will do then is it will create a new vector that starts where you started, ends where you ended, and that will be A plus B. And that's that. Okay, fairly straightforward. It is worth mentioning that if you were to do it in the opposite order, it would not make a difference. So we could start with B and then have A, and it will give you, now obviously my drawing's not perfect, but you can see the idea that this is exactly the same as that. Okay, so it doesn't matter what order you add them in. Alternatively, you can use what we call the parallelogram law. If I'm being honest, this is one that is talked about a lot, but you're probably not really actually using it because it kind of just is a combination of both triangles. So I'll show it to you though. So this is basically, you take the tails of A and B, and you just create a parallelogram with it. So basically we're going to have, so that's A, that's B, and so you're going to extend B off of here as well, except that you'll draw it in the direction that it actually goes. And then that's A. Okay, so you basically, you're doing the triangle twice kind of, and it's just creating this in here, which is going to be your A plus B. All right. So it's one that it's a lot of the rules we will use moving forward will come out of this parallelogram law, but when you're adding or subtracting vectors, you typically just use the triangle law. It's a lot easier. Okay. So for example, whoops. If we take a look here, we have A. We're going to do A plus B. So we have A, which just goes here. Remember that the location of a vector doesn't make a difference. So the fact that I've drawn it here really doesn't matter. And then I'll have B like that. And that will give me, oh, whoops, A plus B. All right, I should label these as well, I suppose. Okay, fairly simple. Here we'll do B, and we'll add C, and this is just going to give us that this is B plus C. All right, I'm not going to label it. Oh, I'll label it. I like to be lazy, but I'm also kind of a completionist. So A plus C is going to go A, and then we'll have C like that. So that's A, that's C, and so that gives us A plus C. And you can see that I am definitely using a ruler here, and these are all perfectly drawn. Okay, so I'll let you take a chance to do these ones in example 2 yourself. It says use parallelogram law, but honestly, just use the triangle law. There's no advantage to the parallelogram law. So for this next one, the polygon law, the idea is that if we add them up, if we just keep on adding on to it, it will work. It doesn't matter how many vectors you add. So if we just keep adding, you take your vector and you take the sort of the tail end of the next vector and you match it up with the head, and you just keep going. It doesn't matter if we started here and we end here. All that matters is that our resultant vector, which it calls S, will just start from where we started and end where we ended. Okay, and that's it. That's the polygon law. Okay, so I'll do a couple of these. I'm not going to do all 3 of them because I don't want this video to go on forever. We'll do the first one though. So there's A, okay, and then we'll add B, and then we'll add C, okay, and so that tells us that the resultant vector just starts where we started, ends where we ended, so that is A plus B plus c. Okay, and you just do the same thing for the other two as well. So I'll let you handle those on your own so we can get into some harder stuff. So the next thing we're going to talk about is magnitude of a vector sum. So first of all, we got to remember the sine law here. Actually, we don't even really. Well, yeah, we do. But the cosine law is the more important one here. But we're going to do this anyway. The sine law can come up, and this will help you find the direction. And this is just, remember that sine of A over A is equal to sine B over B over sine C over C. So once you've drawn your things, that will help you find the direction. But what's perhaps more important in the context right now is that you need to remember this cosine law, which is just that c squared is equal to a squared plus b squared minus 2ab cos c. All right, and so we can actually use that. And so you can see here, you've got, this is drawn out like a parallelogram. Just like I said, it's not necessarily useful when you're using it yourself, but it is where a lot of these rules come from. The important things here are, you'll notice, so this angle, this theta, is the angle that's created between the two vectors. And if you extend this over here, you can see that theta is also located here. And the reason that's important is because our formula is not going to use theta. It's actually going to use this, I think that's a gamma. I'm not sure, if I'm being honest. I don't remember my Greek alphabet. But we're going to use that gamma, and you can see that gamma adds with the theta to create to give you 180 degrees. Okay, so we'll write that down first. So first of all, gamma is equal to 180 minus theta. So that's important because our formula is going to use that. So the formula that we create, because it is just a triangle, then we can just use the cosine law, and we can say that the magnitude of a plus b squared is equal to the magnitude of a squared plus magnitude of b squared. There's a good chance you're going to miss one of these squareds at some point. Don't feel bad, but try not to, obviously. We do 2ab. I think I'm getting messier as I go on. I'm also forgetting my vector signs. Forgot a couple of them. And then it's cos, what we're calling gamma. I'm pretty sure that's a gamma. Anyway, so that's it. That will give you your magnitude. All right. So the other thing then, if we look at this, I was gonna gloss over this, but I'm not going. I should. You might need to know this. So you'll also notice we've got. So I've labeled this angle here alpha, this angle here beta. Beta just goes from here to here. Alpha just goes from here to here, and then again we do have the. And the more I think about it, this is definitely a gamma. And so we can actually use. We can use the sine law to figure out the direction. Okay, so we can figure out those three angles, which will tell us what we need to know. So let's see. I'm going to get the wrong things here. So A goes with alpha. So we've got, which makes sense, I suppose. So we'll say sine of alpha is equal to the magnitude, or over the magnitude of A is equal to sine of what I assume is beta. I'll double check that on my diagram before we move on. Yes, B is across from beta, which gives us sine of gamma is across from C, so the magnitude of C. And so you can use that to figure out those angles, okay? And it works just like any other sine law question. The fact that they're vectors is kind of irrelevant, okay? All right, so I'm going to let you do those examples in either by yourself or at the beginning of class, unless you're watching this during a pandemic, in which case there is no class, in which case please try to do your best. Anyway, vector subtraction. Vector subtraction is it's basically exactly the same thing as addition, except backwards, not surprisingly. So what we'll do is we would take A. Actually, I'm going to put A a little lower because I need the room. So I'm going to draw my A right there. So that's A. And there's a couple ways you can think about this. But what you're effectively doing is instead of starting here and going here with B, what you're going to do is you're going to go backwards. You're actually going to draw B backwards. I meant to use red there. It doesn't matter. So the B is going to go, I guess it's a little longer than that. So that's our B. Oh, except that I messed up there. So anyway, so you put the head to head, and then this, what we've created then, is going to be your A minus B. Another way to think about this, because to be honest with you, even though that's sort of the more common way of talking about it, the more common way of doing it, that's not actually how I personally do it. What I do is instead I think about the fact I've got A here, okay, and then I think about the fact that if this here is B going from there to there, then that means that negative B goes from there to there. It's the exact same, but the arrow would go on the other end. And so I actually like to just add negative B, which is exactly the same thing. Adding negative B is the same as subtracting B. And as you can see, it will give you the exact same result in vector. So that's how I do it. It's a little easier to think about as far as I'm concerned. But if you disagree with that, that's fine, because it's the same thing. There's no advantage of one way or the other. So anyway, so let's just quickly do a couple of these. So we've got vector A, okay, and we'll subtract vector B. So we put the head to the head, and that will give us, I better use yellow. That will give us A minus B. So that's A, that's B, and so that's A minus B. Okay, so I'll let you try the other two on your own. And then the only other thing that we will need to talk about is the zero vector. And the zero vector is interesting because what it is, a way to define it is just say, well, if you took any vector B and you subtract itself, what you're left with is the zero vector, which we just write as a 0 with the vector sign. And the magnitude of the zero vector then, obviously, is just equal to 0. So it has no magnitude. It also has no direction. Okay, and so it has no magnitude and no direction. And yeah, so it's a very useful tool that will come up over and over in various ways. It doesn't seem obvious right now necessarily, but trust me, it will. And so then the next two examples, I want you to try yourself, and then we'll do them in class. Okay? So until next time, go Sabres.